Today I want to solve an exercise, first exercise in second session 2019 LS. Given the points A 6, 0, 0 and B 0, 6, 0, C 0, 0, 6. Let gamma be the circle circumscribed about triangle ABC. First question is so easy. Show that the triangle ABC is equilateral. To prove that the triangle ABC is equilateral, we have to calculate the lengths of AB, AC, and BC. How can we calculate the lengths of each side? We can find the coordinates of each vector and applying the rule of the lengths. Example, vector AB is xb minus xa, yb minus ya, and yc minus ya. So it's minus 6, 6, and 0. So AB equals 6 radical 2. Same method, BC equals 6 radical 2, and AC equals 6 radical 2. So ABC is an equilateral triangle. Okay? Second question is, write a Cartesian equation of plane P. The plane P is determined by the 3 points ABC. Also, it's easy. How can we find the normal vector of this plane? This plane is determined, the plane P is determined by the 3 points A, B, and C. So the normal vector P of this plane is AB vector product AC, or AC vector product AB, or BC vector product AC. Okay? It's equal to 1, 1, 1. So the plane P has an equation x plus y plus z plus r equals 0. A is a point on the plane P, then the equation of this plane will be x plus y plus z minus 6 equals to 0. Okay? Third question is part 3a. Show that, رح نكتبها هذا question. Show that the point H of coordinates 2, 2, 2 is the orthogonal projection of O on the plane P. We can draw a figure. We have a plane P, and we have a point O doesn't belong to this plane. The question is, show that the point H is the orthogonal projection of O on the plane P. To prove that H represents the orthogonal projection of O on plane P, we have to prove two statements. The first one is H belongs to this plane. H belongs to this plane. It's so easy. We can replace the coordinates of H, 2, 2, 2, in the equation of the plane P. And we obtain 0 equal 0. So H belongs to P. It's easy. Okay? And to prove that H is the orthogonal projection of O on the plane P, we have to show that OH and NP have the same direction. NP is the normal vector of the plane. What's the meaning of normal vector? I mean the normal vector is a vector perpendicular to the plane. So if the vector OH has the same direction of NP, so OH is perpendicular to the plane P. We calculate the coordinates of the vector OH. The coordinates of point O are 0, 0, 0. Since 0 is the origin of the orthonormal system, or IJK. Okay? OH is 2, 2, 2. So it's clear that OH is equal 2 times NP. The normal vector of plane P is the vector having the coordinates 1, 1, 1. So OH 2, 2, 2. So it's easy to show that OH equals to 2 NP. Then OH is perpendicular to the plane P. Okay? OH perpendicular to the plane P, and the point H belongs to the plane P. So now we can say that H represents the orthogonal projection of O on the plane P. We repeat to prove that a point represents the orthogonal projection of a point on a plane. We have to show that two statements. The first one is the point H belongs to P, and the vector OH and NP have same direction. Okay? Part number 3B. 3B. Prove or verify that H is the center of the circle gamma. Gamma is the circle circumscribed about triangle ABC. Okay? What's the meaning of circle circumscribed about triangle ABC? This is a circle, and this is the triangle ABC. Circle circumscribed about triangle ABC, I mean the three vertices. Yani each one is called vertex. A is the first vertex of triangle ABC. B is the second vertex, and C is the third vertex. In plural, we call vertices. So, what's the meaning of circle circumscribed about triangle ABC? The three vertices A, B, and C belong to the circle. To prove that H is the center of the circle, it's easy. We can calculate HB, HC, and HA. If they have the same lengths, so H belongs to the circle circumscribed about triangle ABC. HB equals HA equals HC. All are equal to 2 radical 6. Okay? So H belongs to the H represents the center of circle gamma. Okay? Part 3. Part 3C, show that the volume of tetrahedron OABC is the triple of the volume of tetrahedron OAHB. Volume of tetrahedron OABC equals 1/6 absolute value of determinant of the three vectors OA, OB, OC. By simple calculation, we can find the determinant than the absolute value of this determinant. Then we divided this quantity by 6 and we obtain 36 U cube. Okay? Same method. Volume of the second tetrahedron OAHB equals 1/6 absolute value of determinant of the three vectors OA, OB, and OH. It's equal to 12 U cube. We remark that the volume of OABC is equal to 3 times volume of OHB. Part 4. هلا part 4 يا شباب هي البارت المهمة، مش معناتها انها صعبة بس هلا بتشوفوا it's easy but it's very important. Consider the line D of equation x equals 6, y equals minus m, and z equals m, with m is a real parameter. Okay? The first question is show that the tangent of D, show that D is the tangent. Show that D is the tangent to the circle omega at the point A. Okay? We can draw a circle. This is a circle of center H, and a point A belongs to this circle. Show that the line D is tangent at A to the circle gamma. How can we prove this statement? If we calculate the scalar product of the directing vector, what's the meaning of directing vector or direction vector? Is a vector having the same direction of the line. So the relative position between the line D and its directing vector, they are parallel or confounded. واحدة منهم. إذا كان هيدا direction vector. Okay? سميناه SD. If we calculate the scalar product of SD and with the vector AH, and we obtain 0. So the two vectors SD and AH are perpendicular. So perpendicular. What's the meaning? SD is perpendicular to AH. I mean the line D is perpendicular to the radius. And we have line D is including in the plane. If we look on the given figure in the exercise, we remark that in the plane P we have a circle circumscribed about triangle ABC and the line D. So the line D is including in the plane P if we use the figure in the given. Okay? So now first step is to say that the line D is including in the plane P. Okay? Second step is to find the coordinates of the directing vector of the line D. The line D is given x equals 6, y equals m or minus m, and z equals m. So the directing vector is 0, minus 1, and 1. The coordinates of vector AH are, we have the coordinates of point A and H, their coordinates are 2, 2, 2. 2 minus 6, it's minus 4. 2 minus 0, it's 2. And 2 minus 0, it's 2. We calculate the scalar product between these two vectors. 0 times minus 4 is 0, minus 1 plus 2, it's minus 2, plus 1 times 2, 2, so it's equal to 0. Then SD is orthogonal to the vector AH. SD is orthogonal to the vector AH, so D, line D, is perpendicular to the line AH. Then D is tangent to circle gamma at point A. اوكي؟ هيكون خلصنا البارت A وفضلنا البارت B. بالبارت B let D prime be the tangent to gamma at point B, and I is the point of intersection of D and D prime. Show that the 3 points I, H and C are collinear. خلينا نرسم الفيجر ونفهم شو عم بيصير. We have a circle of center H and A is a point belonging to this circle. We have a tangent passing through A to the circle and a point B belonging to the circle. We have a second tangent to the circle passing through B. The first tangent is D, the second tangent is D prime. These two lines, D and D prime, intersect at point I. The question is, prove that the 3 points I, H and C are collinear. The question is, show that I, H and C are collinear. To prove that these points are collinear, we have to find the coordinates, or to calculate the coordinates of point I. Point I represents the intersection between the line D, the first tangent, and the line D, the second and the line D prime, the second tangent. But we don't have the Cartesian equation of the second tangent D prime. So first step is to find or to write the Cartesian equation of the straight line D prime. D prime is the tangent at the circle, or at the point B to the circle gamma. And the circle gamma and the tangent are including in the plane P. So the direction vector of the line D prime is equal to NP vector product with BH. ليش ال BH شباب؟ The line D prime is tangent to the circle gamma at point B. So the line D prime is perpendicular to BH. يعني أنا بدي vector يكون perpendicular على BH، فما لي غير normal vector of P vector product BH. Since by construction of the vector product, I mean the answer of this vector, give me a new vector perpendicular to the first one, perpendicular to the second one. أيوة مشان هيك NP vector product BH represents the direction vector of the line D prime tangent. أنا عامل لها calculation حأعطيكم دغري الأنسر. الأنسر equals 6 0 minus 6 by using gamma rule ijk, determinant ijk, we obtain 6 0 minus 6. We can take another one so easy. يعني فينا نعمل division كلياتهم by 6. So s d prime فينا نعتبره انه هو equals to 1 0 minus 1. استاذ فينا نستخدم 6 0 minus 6 ما في مشكله، بس هيك اهين. هيدي الميثود بستخدمها بكل شيء في دايركشن فيكتور او نورمال فيكتور، مش فرقانه معي يا شباب الا بوقت ما بكون عم بجيب الاريا. ما فيني اقسمهم لانه الاريا بتكون هي length of this factor divided by half، ونفس الشيء بوقت الفوليوم. اوكي، اما بكون عم بجيب نورمال فيكتور او دايركتنج فيكتور ما في مشكله نعمل ديفيجن. فاذا نحن صار عندنا دايركتنج فيكتور d prime is the straight line passing through B tangent to the circle gamma. Okay, so the Cartesian equation of this line is x equals t, y equals 6, and z equals minus t. And هون البوينت B belongs to this straight line. Okay, B coordinates تبعونا هن 0 6 0. احنا بهالطريقة we find the Cartesian equation of the straight line d prime. Why? لأن احنا بنعرف إنه ال I represents the point of intersection between d and d prime. هلا بعمل system between the two straight lines d and d prime to calculate the coordinates of the point I. اوكي، لو بدي اعمل سيستم بدي احط اللاين دي برايم. شو كانت الايكويشن تبعيته؟ x equals t, y equals 6، هذا الدي برايم، z equals minus t. هلا اللاين دي can be given in terms of m. x equals 6, y equals minus m, and z equals m. x equals x, y equals y, z equals z. So we obtain t equals 6, m equals minus 6. يعني if we replace t by 6 or m by minus 6 we obtain the coordinates of the point I. Okay شباب, by replacing t by 6 or m by minus 6 we obtain the coordinates of I. So point I, replacing t by 6 in this equation or m by minus 6 in this equation. So I, the coordinates of point I are 6, 6, minus 6. To prove that the 3 points I, H, and C are collinear, we have to calculate the coordinates of two vectors constructing by this point. IH, H minus I, 2 minus 6 is minus 4, 2 minus 6 it's minus 4, and 2 minus minus 6 it's 8. HC, C minus H is minus 2, 0 minus 2 it's minus 2, and 6 minus 2 it's 4. We remark that IH, the vector IH equals 2 times vector HC. Then IH and HC have same direction. Okay? Have same direction with H common point so I, H and C are collinear. اوكي شباب, خلصنا الاكسرسايز هيدا ومثل العاده بنضلنا على تواصل. يعطيكم العافيه.